Hello guys, welcome to my channel. So today we are going to study of compounds hydrogen chloride. So topic to be studied are occurrence of hydrogen chloride gas, its general preparation, laboratory preparation, its physical and chemical properties. Now its occurrence. Glauber prepared the acid in 1648 by heating sodium chloride NaCl, or we can also call it as a common salt. Lavoisier named it as muriatic acid. In free state, occurrence in volcanic eruption is there, and 0 to 2 to 0.2 to 0.4% is present in gastric juice of mammals. Now you might be thinking, why is it present? So due to its presence, the inactive pepsinogen becomes active pepsin, and this pepsin break down the digested food into proteins. Now its general preparation. Now the first type is by direct combination. In that we have to take moist hydrogen gas, which is combined with chlorine in the presence of diffused sunlight. The sunlight should not be direct and there should not be darkness. So in note we will be further talking about it. The reaction is explosive in in direct sunlight, but it is negligible or not possible in dark. But in dark we can perform it by the presence of activated carbon. But it is preferred to perform it in diffused sunlight. Now second method is by heating metallic chloride with concentrated sulfuric acid. We can see metallic chloride like sodium chloride and copper chloride. They form their particular salt and the hydrogen chloride gas is evolved. Now the most important topic is laboratory preparation of hydrogen chloride gas. So in this we can see, so the reactants which are take place is sodium chloride, this sodium chloride, and concentrated sulfuric acid. These are the two reactants which are there in this preparation experiment. So in that what the procedure is, place some common salt in a flask, this flat bottom flask, okay, and pour concentrated sulfuric acid through the thistle funnel. So the thistle funnel should be properly dipped into this sodium chloride. Now the reaction proceeds slowly in cold, so we have to provide heat gently, not vigorously. The gas is dried by passing through washer bottle. This is the washer bottle. In this, concentrated sulfuric acid is there. Now it is collected by upward displacement of air in a gas jar. Here upward displacement of air, by this process the hydrogen chloride gas is produced. But why your water is not taken? The reason for it is highly soluble in water, because of which it will get dissolved in water and we will not be getting the hydrogen chloride gas. That's why we take upward displacement of air in a gas jar. And why upward displacement? Because it is heavier than air. Now let's see the reaction. The reaction is NaCl plus H2SO4 at the temperature below 200 degrees Celsius give NaHSO4 or sodium bisulfate plus hydrogen chloride gas. Now if we increase the temperature above 200 degrees Celsius, sodium sulfate is formed and hydrogen chloride gas is evolved. Now it is preferred to take the temperature below 200 degrees Celsius. The reason is that sodium sulfate, which is formed in the temperature above 200 degrees Celsius, it forms a very hard crust. and it become very much hard to remove it, because of which we prefer to take the temperature below 200 degrees Celsius. Now before moving towards physical properties, let's see some precautions and identifications. So the precaution that should be taken is the lower end of Thiessen funnel must be dipped into the concentrated sulfuric acid. Means the solution I have told you. So the solution I have told you, wait a minute please. Yeah, so this solution, the Thiessen funnel should be dipped into this solution. Then the next precaution is delivery tube should not be dipped in drying agent, that is concentrated sulfuric acid. Why over here concentrated sulfuric acid is preferred? Because other drying agent like phosphorus pentoxide, quicklime, why they aren't preferred? The reason is that they react with hydrogen chloride gas. Thus, concentrated sulfuric acid is preferred. Now there is some identification process as well. We all know that HCl gas is evolved, but we need to prove it. Okay, so for that we have to take the HCl gas, means the product of this experiment. We have to take that plus ammonium hydroxide, or ammonia will also be preferable over here. It will produce ammonium chloride, and the nature of it is dense white fume. Dense white fume of ammonium chloride will be produced with water as its product. Now let's move toward the physical properties. So the physical properties, what is the color? The color of the gas is colorless. The smell is pungent choking smell, and the taste is sour because of its acidic nature. Its physiological nature is corrosive. It means it irritates our nose and throat and lung. Its density, it is about 1.25 times heavier than air, or Vd of hydrogen chloride gas is 18.25 and air is 14.4. So here we can clearly get an idea that hydrogen chloride gas is much heavier than air. The boiling point is 83 degrees Celsius, minus 83 degrees Celsius. The melting point is minus 113 degrees Celsius. Liquefaction and solidification. When it is subjected to high pressure, that is 40 atm, at a low temperature, which is 10 degrees Celsius, it gets liquefied to a colorless liquid. Now its solubility. Hydrogen chloride gas is highly soluble in water, and due to its polar covalent compound, it is soluble in organic non-polar solvent like acetone and toluene. Now experiment to demonstrate the density of HCl gas. So first we have to take a jar, and in that the lighted candle is there. We have to pour which contains air, and then we have to pour hydrogen chloride gas in that jar. So you can see the candle extinguish, because hydrogen chloride gas is much denser than air. It goes down and settle over there and push air outward, because of which candle doesn't get oxygen. Thus hydrogen chloride gas is much denser, that's why it's pushed the air outward. Now experiment to demonstrate high solubility of HCl gas. So we have to take a round bottom flask, inverted it. There should be a rubber stopper which has 2 holes. through one hole there must be a long jet tube pass through, and to other there must be a dropper which contains water, and the end of the jet tube must be dipped into blue litmus solution. Now what you have to do, that the HCl gas which is present in the round bottom flask, in that round bottom flask we have to press the dropper and the water will go inside that round bottom flask, due to which HCl has a high solubility, thus it will react with water, and as water enters the flask, the outside pressure being higher push the blue litmus solution inside the jet tube, and as the blue litmus solution reacts with this hydrogen chloride gas and water's mixture, it forms a red fountain or a red litmus solution. So you can say that it proves the solubility of HCl gas, as well as it also proves that HCl gas is acidic in nature. That's why it's turned the blue litmus solution to red. Now its chemical properties. First is combustibility. It does not burn, rather it extinguish a burning splint. It's in thermal dissociation. On heating above 500 degrees Celsius, it dissociates into hydrogen and chlorine. Now with metals, it form metal chloride, and hydrogen gases evolved. Metals such as sodium, calcium, magnesium, zinc, iron is stacked, and it's react with the hydrogen chloride gas to form its metal chloride. Now its reaction with ammonia, it combines with ammonia to form dense white fumes of ammonium chloride. So I have also told that ammonium hydroxide will also work over here, and ammonia will also perform the same task. So it can be an example if a question is asked that give an example of two gases combined to form a solid, so it can be one of its example. Thank you all for watching my video. Please like, share and subscribe, and stay tuned for getting more educational video. And it's really mean to me. Your one subscriber means a lot to me. Thank you everyone for watching. Bye. Stay home, stay safe.